Hello, welcome back. So my name is Saptak Sen again, and I have with me Bill Ramos.
Hi, I'm Bill Ramos, VP of Consulting Services with Advaya, and I'm here to help Saptak out demo some MapReduce in this new module here.
Awesome, awesome. So let's talk about quickly what we are going to show in this module. First of all, we are going to discuss the concepts of MapReduce. It's very important because that's the processing paradigm for Hadoop. And then we are also going to do some demos around how you can write your own .NET MapReduce jobs. So with that, let's get started on what MapReduce is. First of all, in any parallel or parallel platform or distributed platform, the key issue is that any time that we have to work or wait for one process to finish on another node to continue, it decreases the parallelism. This whole process is called synchronization. And synchronization is the worst enemy of parallelism, right? So, and if we lose parallelism, what that means is that we are not efficiently using the resources, the compute resources that we have at our disposal, because some other process in some other node is waiting for another process on another node to finish up. So this is very, very inefficient. So the idea is to minimize this kind of synchronization. Now MapReduce by design is a processing framework which tries to minimize this any kind of synchronization to the extent possible, right? Now, as the name suggests, there are two main phases, the map phase and the reduce phase. Now, of course, there are many other phases that the framework provides, but essentially what the map phase does is that as you have data, like we talked about in the last module, sharded up across all these systems and all these drives, you spin up this little programs or tasks called mappers. And these mappers can work parallelly through ingesting all that data and do the first level of processing, like filtering, taking out stuff which you don't care about from the raw data and just extracting out the important data or transforming some data. Now, once that has been done, they put little kind of almost category tag, and that's the key of the key value pair, right? So around MapReduce, you'll hear about the term key value pair a lot, right? So as we are reading in data, we are extracting entities that we are interested in and putting on little labels on those entities, right? And those are the keys. Now, once the mappers are done with it, it emits those out to the framework. Now, framework takes care of shuffling that and sorting that in a way so that the reducer, each reducer, and there could be many reducers, gets a bag of key value pairs where all the key value pairs have the same key, right? So now the reducers can combine or aggregate across all these key value pairs with the same key, right? Each reducer can do it. So that way you get parallelism in the mapper phase and you get parallelism in the reducer phase. That's the whole motivation of MapReduce. Now, you could do it with just, say, Windows socket programming, all this, right? But it's going to take you a lot more lines of code, and you have to take care of a lot of things yourself, which the MapReduce framework here is giving it to you for free, or already baked into the framework. You don't have to worry about it. So that's essentially it. Now, with that in mind, let's look at the hello world of MapReduce programs. if anywhere you go to learn MapReduce, they show the word count problem. And yeah, so over to Bill with that. For that.
Okay, so let's show you the word count program as it's set up on our HDInsight cluster. And so there are several different versions of the sample that are set up with HDInsight, but I just clicked on the sample tile, and if you look down here in the lower corner, there's this thing called word count. Now, any one of these samples has an ability to quickly deploy to a cluster. But let's go through a couple of examples that are shown here. You can interact with this independently, where you're just uploading a particular data file to the system and then running the word count. You can run it just by hitting deploy to the cluster, which we can do. In addition, there's a version of this in JavaScript that can be run as well. So what I'm going to do is just simply go deploy to cluster. What this does is it launches the create job dialog, where it has a jar file that's already set up. This jar file is written in Java, which is the predominant language for most MapReduce programs, and Microsoft is coming up with .NET framework where you can actually use .NET programs, but we'll get into that a little later. From here, there are actually several applications or classes that are set up to do the MapReduce job. The parameter indicates the particular one that you want to run in the sample, and then indicates the location of the data file where it's going to go ahead and read in the data here, along with specify the output file for where this information is going to go. So the final command basically saying run Hadoop using the jar notation in the jar file with the parameters that you see here. And at this point, I just say execute job. And so what this does is it goes ahead and spins up the mappers to go ahead and search through the DaVinci.txt, and it's parsing out each word that is part of that text file. And then while it's going through that, it's creating all these keys with all the values in that. And then for each word, the reducer is going through and summing up the total number of occurrences of that word. So to see what's going on, I can go back to my job here, and it indicates that my job history is still running. So I'm going to go back to my task overview, and it says it's complete. So things happen pretty quick. It says it succeeded. I can see by clicking on here the information that was going through here, and you can see the output of our MapReduce job. And so essentially the mapper did its job of going through and collecting the words, and then there was a reduce phase to output the results. Now to actually see those results, I can do that a couple of ways. If I go to my storage container, and actually that's not where I want to go. Let's go back to my console here. Now if you recall back in the last module, we used the interactive console to display the file information. And so I'm going to bring in my little crib sheet here, and the output location what I'm doing here is just specifying the ls command to essentially show the files that are there. And we can see that there were two things that were created. The first one is success, indicating, yes, it succeeded, which is good. This is just a kind of a cookie file to let you know what was going on. And the second part is the actual output of the file. And so if I want to see what's going on there, I can use the tail command, which allows me to see the last essentially 1,000 bytes of characters in the file to see what the result is. And here we can see the last bit of characters. Now it's very important that because this is quote-unquote a big data solution, you don't want to use essentially cat or type command to list your data out, or otherwise it'll just stream like crazy. And so we're using the tail command that's available on Linux operating systems to show the last bit of data for that. So Sopdak, that was the word count. Just like that, we ran our first MapReduce job.
Awesome,
so,
awesome.
Yeah.
So yeah, so Just to explain again, and Bill explained it, I'm going to reiterate it. What just happened was that, in the mapper, as all these mappers on many different systems came alive and started reading their blocks of the file. Now, this this whole file was placed on Azure Blob Stored, and it's all distributed across the nodes, and then different streams of these files started pouring into different mappers, and then they started reading through those files. The mappers started taking out each word and use the word as the key and the number of time they saw the word in that file or in that stream as the value. So most of the time it is the say the word gravity, right? And gravity and the number is 1. And once it's gotten that, all the mappers did all this for all the different words, and then they emitted it to the framework. The framework then sorted it and shuffled it so that each reducer got all the instances of the key value pairs where the key is gravity and the value is, most of the time, it's 1, right? And then reducer basically just aggregates it. So it says, okay, for gravity, I've seen this many values. This is the sum of all the values. So if the word gravity appeared, say, 50 times, it will say gravity 50, thou 10, whatever, right? And then it just writes out to the Azure Blob Store. Now the cool part is, at this point, you could potentially delete the cluster because your job is done. You've run a job, and if it was multiple terabytes of file, let's say you have a very big cluster to process it, and you can now delete the cluster to save you cost. Now with that, let's talk about how you can do with .NET. For .NET, we have a .NET SDK. Now, the easy way to get that .NET MapReduce API into Visual Studio is through something called Nougat. And Nougat is very similar to Git, if you have used Git, right? It's basically a utility which lets you very easily download and import these libraries within your Visual Studio environment. Now, as part of this, you get the libraries, not just the libraries, but you also get the stubs which will be used like MR Runner and so on to start your MapReduce programs. Now, the MapReduce programs that you build here are typically DLLs, and the stub now launches the methods in those DLLs and does the mappers and reducers. That's all it does. Now with that, we have a demo for how to create a mapper using C#.
Thank you, Saptak.
Yeah.
So what I'm going to do right now is use Visual Studio to create a new project for our mapper utility. Now, Saptak indicated that most of the time these are actually DLLs, but in this case we're going to actually create an exe that'll then be uploaded and then run as part of the C# streaming mechanism. In a future module, we're going to show how you can actually use a DLL to go ahead and create your class and then use that for running your job. So let's go ahead and go to Visual Studio right now and create our new project. So what I'm going to do here is we're going to create a console app for our application, and I'm going to name this Big Data Bootcamp Mapper. Now again, I'm just making it tough on myself with all the upper and lower case characters. Again, things will be case sensitive, but this is why we have clipboards and things like that to keep us handy, or keep us in sync here. So we've got our console app, and at this point I'm going to go ahead and click OK to fire things up. Now this has created a shell program called program.cs that we're going to replace out here in a moment. So what I'm going to do is create a new application file. And again, this will be C#. Where is my, class file right there at the top. Okay, and I'm going to call this map.cs. Okay, so we have our map.cs file, and at this point I'm going to copy in the code that we're going to use for this class, and then I'll walk through it here in a moment. Now, again, this SEPDAC indicated that these MapReduce programs can do things like filtering and other kinds of operations. In this case, we're going to actually do a transformation of our data so that it makes sense when we're loading it into tools like Excel. So let's go back up to the top. Now, if you notice here, there's a little squiggly mark under Hadoop, and this is because we have not added our reference to the Hadoop classes using Nougat. And so that the way that we do that is we go ahead and go to the Tools menu and the Library Package Manager and use the Package Manager console. And from here, what we're going to do is issue a command that will go ahead and download the package for our MapReduce right here. Okay, so if we go down here, what we're going to do is tell Nougat to install this package called Microsoft Hadoop MapReduce to resolve that particular item. So we'll go back here and hit enter. And so this is going through out to Nougat, downloading the libraries. And let's see, we all done? Yep. So we can see now there are a whole bunch of references in here, including the Microsoft Hadoop MapReduce. And now our little squiggly mark under Hadoop has been resolved. So we have a mapper program that is all ready to go. So let's take a quick look at what this application does. So what it does is it uses these, the stream reader method to go ahead and load in the file and then reads one line at a time. Now again, the mapper, because it can think of it, when HDInsight or Hadoop executes this, will actually take the stream of data and actually spin up a bunch of mappers, and each one of them will go through and figure out how to read the file at a given time. So it can actually read this information in parallel for really large files. Now in this case, the data file is fairly small, so we might not see much parallelism that takes place in the output result, but it just gives you an idea. By writing these small programs using the stream reader and the read line, it'll actually spin up as many tasks as it possibly can to process the data more efficiently. So let's take a look. The next thing we do is we're basically taking our common delimited file and splitting it up into an array. Where we're going to start building out our key value. In this case, our key value is going to be our age range here. Now, if we go back to our file, what this is basically doing is saying that the character in the 8th position, because everything is 0-based here in C#. So what we're doing is we're saying column 1, 2, 3, 4, 5, 6, 7, 8. That one right there. Okay. This column represents an age group, and what we're going to do is, based on the age group mapping that were in the census file, we're going to map these 1s and 2s and 3s into a character value as part of our mapping key program. So we're essentially saying if it was 1, then it's 0 through 4, and these were all the ranges that were set up by the Census Department. Now the other thing we need to do is we've got to output our key value pair. In this case, what we're doing is we're taking the values in positions 3, 4, and our key, which is this age range here, to build our key that will be our unique identifier, and then taking our 9th value, which is the population value. So let me flip back here. So again, sorry about bouncing back. We're taking 0, 1, 2, 3. So that's our state, 3. This is our county, 4. and then this is the last position, which is represented by our value in 9. Now this last one here is actually tab delimited so that it can keep track of the key value pair for our reducer later on. To get things kicked off, I'll go ahead and I need to delete this program here. And so I'm going to go ahead and delete that class file. And so we have our mapper. I'm just going to go ahead and build. And build succeeded. We're all set. We've now created our mapper, and it's time to kind of click over and build out our reducer after this. But
awesome.
That's our first step here.
Let's do the reducer
Let's do the reducer, man. Okay. Okay, so for the reducer, we're going to take the same, very similar approach. We'll go ahead and create a new project again. And in this case, since we're flying through the script here, let me get my little cheat sheet here. Okay, so we got our mapper, and now for a reducer, what I want to do is call this Big Data Bootcamp Reducer. And again, that will be stored in our applications directory. And we're going to take our very similar approach as the other program. So what I'm going to do now is create a new class file. And I'm going to name this, let's make sure I get this right, reduce. Okay, so now that I have our reducer, I'm now going to paste in the code and we'll walk through that here in a moment. So I'll go. Okay, so go back up here. You see, again, because we've created a new project, we don't have the reference set up for our library, so we have to do the Nougat routine again. So we'll go ahead and go back out to our console here.
Package manager.
Our package manager, yes, thank you. And Visual Studio was kind enough to retrieve the keyboard buffer so I could do an up arrow and go ahead and hit that thing again, so I don't have to do it more than once.
Nice.
Okay, so now we have our reduce program. I'm going to kill off our program.cs, and all our references are all set up, and let's walk through what the reducer does. So again, the program is built for parallelism in mind. It uses a stream reader to read in the data from the mappers, and it's using essentially the read line to then go ahead and do a similar thing. In this case, what we're doing is we're going to split. Again, we had our key value, which consisted of the state, the county, the age group, which has now been mapped out to 0 through 4 years and so on. And we have our value, which is the population. And so if we look down at the code, what this is doing here with the line split is it's using the tab as the way to determine how things got split out. So our key is the first part, and our value is the second part. Now that we have that part, what we're going to do is we go through, and the mapper will go through and look to see for each value that's a key, it will take and add the value back, or add the value for those keys, because each line represented a race, a sex, and all that, and so there's actually multiple lines per age group that each thing now is summing up as part of using this count routine in the reducer. So the reducer, I've seen it primarily used for things like doing aggregation. That's what it's very good at doing. And so now if we go back to the code, this count for the key will go ahead and keep track of all the particular items for that age group now, and then write it back out to the console. So what we're doing is we're taking this output, and by writing it out, now the Hadoop streaming system will use that for its final shuffling and assembling of the data. So that's our reducer, so I'll go ahead and save that and build the project. And now that I've got it built, I want to show one other thing here. If we go back to our application space, because we're going to need to keep track of our programs, you see there's a directory folder for our mapper and our reducer, and I'll just dig into one of these here where we look at in the bin directory under debug, we have our mapper.exe here. Now, one thing to keep in mind when you're working with the system is make sure that you keep track of which file's the application versus which one is the XML configuration, because they look very similar. So what we're going to do later on is we're going to upload the mapper and the reducer to run our job. Saptak, you want to take it here? We've got our mapper and reducer now.
Absolutely. So
close here.
Why don't we just run that?
Just run it? Yeah, why not? Just get it over with, man.
Get it over with.
No, it's a lot of fun here. So what we're going to do is we're going to actually use a sample program to kind of kick things off. And the reason being is that there's some setup that has to take place when we create a job that isn't normally available when we just say a new job. Specifically, what we're going to do is use this C# streaming sample. And we're not actually going to use the code or anything like that, but it has a jar file that's set up to run our two exes that we'll go ahead and replace the parameters on. And so now that we've got the setup here, we're going to delete most of this stuff and call it our own stuff. And so we're going to call this our MapReduce demo. And for our parameters, I'm going to flip back over to our cheat sheet here, because actually I'm not quite ready to run this yet, and I'm glad I didn't. Whew, that was close. So what I actually have to do is I'm going to go back to our interactive console, because the thing I need to do is that we have our mapper and our reducer. I now need to put it up into our Azure storage.
Yeah.
Minor problem. Yeah, so
it's all on your local machine.
Yeah, somehow we've got to get that over there. So what we're going to do is I'm going to go ahead and create some directories here, or pseudo directories on our Azure storage. So let me go ahead and copy that to clipboard. So what we're going to do here is, let's see how well this works, is we're going to use the makedir command, and in our working container and in our storage account here, we're going to create essentially a directory called MapReduce Student ID Apps, and that's where our application will go. So we'll go ahead and create our directory for that. And I'm going to do a similar thing for our data. I'm going to regret having to type this in rather than use the keyboard, so let's hope that isn't the case. So we have our apps directory and our data directory. Now, one of the things that I'm doing here is that I've created a separate data directory. Remember, I've already uploaded my census dat files to the root directory of the container on Windows Azure. But what MapReduce does is when you specify an output folder or an input folder, it will read everything in that input folder and process it as if it was all related to each other. In that case, if I specify the working root, it's got a bunch of stuff. It's going to do something that's not very desirable. And so that's why what I'm going to do is I'm going to copy the files from our root of the working container over into this directory. So let's go ahead and do that. And this operation should be fairly fast because it's all happening on Azure storage. So it's not as before when I had to use the Azure Storage Explorer. It's not actually copying it back down to my workstation and back up. It's all doing it on the system. Okay, so there are two parts to this command. We're doing the copy of our census data.dat file, and we're just giving it the destination of that being our working container, and then into our data file. And we'll do the same for our second file. So you see that happened pretty darn fast. Just to make sure, because I'm a little bit paranoid here, I want to make sure it copied over okay. We'll use the ls command in our data directory, and we see our 2 files. Okay, so far so good. We've got the data now. Next thing we need to do is upload our exes. To do that, we're going to use a function called fs.put. And this is one of many functions that are available on your interactive JavaScript console that I'm going to run. And this allows you to upload relatively smaller files. So what we're going to do is we're going to bring in our mapper.
So Bill, we could have also used the tool that the Storage Explorer, Azure Storage Explorer, to do this, right?
You know, so that's a good question, Saptak. So far I haven't been able to figure out how to use Storage Explorer to actually go through and tell it a directory to where to put the file. And so actually I need to use fs.put here to get things going.
Okay.
Yeah.
So the other one that you can use is azcopy.
azcopy, awesome tool. Yeah.
So azcopy is the utility where you bring up a very important topic. The topic is that because, as I was saying, the Azure container is just one level, that's why you can't create a folder within the Azure Storage Explorer. But with azcopy, what you can do is make the folder name, so to say, as part of the name of the destination file. So anything that you do from the interactive console, like create or directory or something, it's basically adding to the file name.
Nice.
So that's the emulation.
Why didn't you tell me that earlier?
I thought you need to learn something in the bootcamp as well, right?
Yeah. Okay. Okay, so what we're going to do is go to our application directory and go to our mapper and our bin directory. And here, that's why I said we've got to select that guy. That's the exe. Now for the destination, we need to input the path for our app directory. And I just happen to have that sitting over here. Okay. So file uploaded, that's our mapper, and now it's time to bring in our reducer. So go back to our browser here. Applications, our reducer, bin, debug, and there's our reducer. And again, same path. And press the enter key, and so I'm a bit confused. It said file uploaded. Let's just see if it uploaded. So we'll do a bang ls, and we've got our mapper and our reducer here. So if we scroll over, great. Okay, so now we have our data files uploaded. We have our mapper and reducer exes up on the cluster, or actually on the Azure storage. It's now time to run the MapReduce job. Okay, so to do that, we'll go back to our home here, go back to our samples, C# streaming, and deploy to cluster. Now I can go in and do MapReduce demo. So the first parameter that we need, if we kind of look at the example, is we need to indicate where our word count, or where our mapper and our reducer files are located, and using the files parameter. And so what I'm going to do here is I've got the string already set up. In fact, let me just zoom in here. So what we're doing is we're saying with the -file parameter, we're going to use our working directory and our container in our storage account and indicate that our big data reducer is there and then our mapper is here. So go ahead and copy that to the clipboard and use it for our first parameter. The next thing I need to do is indicate where my input and output directories are. So the input is essentially where the data is coming from, and the output is where I want to place it. And so if I click on that little X, that's another way to clear the parameter values. And I'll tab over here. And so you can see here, we have our input folder, which is the data directory. And so what this will do is take all the data files that are in there and use them as the input. And the output will go into our data directory in another path, or actually we're going to call it Big Data Bootcamp job result. Okay. I'm a little worried now. So we've got our input and output parameter. And finally, we indicate the name of our mapper and the name of our reducer. And the jar file, the Hadoop streaming jar file will know then to associate the exes with the Azure storage that we have here. So let me go ahead and set that up. Now at this point, we have our parameterized version of the final command, and I'm going to go ahead and execute. So what this is doing is processing each of the two DAT files. HDInsight, when it's processing the input files, typically based on the number of your files, a default thing for partitioning is it will actually take the number of files that are in that directory and use that for determining the partitioning and sending out having the mappers do their thing. And if all goes well, I can go back to our job history here, and we see it failed. So let's see why it may have failed, and maybe Saptek can chime in here. I have this bad feeling it's because
with all the copying and pasting.
All the copying and pasting was way off here. So what I need to do...
Input path.
Yeah, the input path and the output path are just a little out of sync here. So we can tell that very simply because it told us the input path didn't exist. So nice thing is it failed quickly. So to fix that, I'm going to go over back to our job. And here I can actually edit the job information in here. And I'm going to go ahead and kill that off. And let's see where I may have messed up. So we have our input directory, which was that right there, which is student ID data. Okay, and then the parameter right here, you see I was missing the ID. Aha.
We need the Clippy for Hadoop.
Yeah. Okay, so there we've got our input directory, and this is actually right. I actually want the data to go into a separate directory called MapReduce_student, and then have its own data file for the job result. So it should go ahead and create that path for us, okay. You notice I had some hesitation when I copied that in there because, Okay, so back here. Okay, side bets for everybody. Take your bets now on whether this is going to work or not. Let's see, so we have our command up to date. We have our student ID data apps, okay. Let's go ahead and execute.
People are betting whether you can copy paste or not.
That's what we're betting. and fix errors on the fly. Okay, so let's go back here. It says running. That's a good sign. So let's go back here. And it says in progress still in our tab here. So you can kind of keep track in the tabs on what's going on with a particular job.
You can also go to the job history, the green.
Oh, this one here.
Yeah.
Yeah.
And it says running. You can click on it once more. It will show much more details.
Should be much more details.
Yeah. It's still
processing.
loading, I guess.
Yep. Okay, well, we've got our mapper doing its thing, and because we're in the cloud, who knows how long things take, but normally this one goes pretty fast.
Yeah.
So I'm going to go bounce back here.
So remember one thing, for the first time when you run,
Yeah.
like any other .NET program, it does do the jitting.
Yes, yes.
The just-in-time compilation.
Yep.
Which does takes a little bit more time than when you run subsequently, because it's all JITted and cached.
Now that we're JITted and cached, if we go back to our display, we'll actually see that the job completed.
Nice.
Nice. So we can see here how the mapper and the reducer did their processing and created our output directory right here. So it actually...
Zoom it.
Zoom it. Let's go first, zoom it. Yeah. So here we can see it created our container with the result. So if I go over here now and go back to our interactive console, and I'm going ahead and pasting in the command for the output directory, we see down here, boink, we have our output file created as part of the listing here. And what I'm going to do now is go back to our command and do the up arrow here and home, tail. I got the insert key on. Okay. Yeah. Insert, insert, insert. There we go. So I'll go ahead and do tail. Go to the end, and that file name was part with 5 zeros, right? And there's our output. So, and it's Wyoming, which is good. It's the end of the states there. And we have our county information, and you can see how we have our data mapped out in a comma-separated file with our total population for each one of the groups. So just like that, what have we done? We've created a mapper with .NET and saw how to actually use readline in there. Oh, there we go. And we've created a reducer in .NET that will go ahead and process the results from the mapper, and then uploaded our data files to or into the right location for our MapReduce job. And then we uploaded our exes there, and then went ahead and used the C# streaming sample app to kind of set up our job so we could input our mapper, our reducer, our input directory, output directory, run the MapReduce job, and see our results, just like that.
Yeah, and those of you who are thinking that, hey, is Tail the best visualization tool we have? The answer is no. We have better visualization tool, and it's coming soon. So don't despair. Hold on. Very soon in the next few modules, we'll cover that. With that, we are done for this module.
Okay, yeah. So in the next module, we're actually going to go through and show you how to use Hive for actually processing this data and use tools. Can't remember if I'm going to go and use Excel or not, but we're going to go ahead and show you how to create a Hive table and get that on, and you can go through the basics on that module.
Awesome. Yeah.
Yeah, thank you.
Cool. Thanks.